So a couple of days we were looking into BGP attribute. The protocol BGP is only because of attributes. So it's worth spending more time. Today let us focus on how to implement. Let's have a case study. So here we're going to look into the more details of how to configure. We use route map. In most of the cases, we use route maps. Not every time, most of the time. You can still have BGP attributes without route map, but most of the time we use route maps. Why? We may not have a common policy for all networks, for all prefixes. We may have few prefixes to follow a specific path. To identify that few prefixes, we need an access list or a prefix list. Now, when you use access list or prefix list, you need to call under route map, using which we can define the path attribute. And finally, we call the route map in the neighbor statement. No problem if you don't understand what I've spoken so far. Don't worry. We're going to go deep into it. We're going to understand. But before we go to the next slide, I just want to give you an introduction to what is route map. Route map is not only meant for BGP, can be used for OSPF, path manipulation, EAGRP, even for policy-based routing, any policy-based routing. We use route map. Route maps are like a very advanced access list. See, the access list can match with source IP, destination IP, protocol, port number. But route map can match with community values, QoS, DSCP values, COS values, attributes, and much more. Route maps not only they match with some traffic, they also can set some attributes to those traffics that got matched. Route map is, as the word says, mapping the route. To map the route with BGP or some other protocol, we need this route map. So wherever we have the policy-based routing, route map can be seen. Policy-based routing is nothing but what? Mapping the route. So PBR, policy-based routing, uses route map. BGP, path selection, is also policy-based routing. Kind of. So you need route map. Now here what we see is an example scenario where policies are involved. Policies. You see, A is connected to X, B is connected to Y. They have EBGP relationship. They are in two different autonomous systems, that's why EBGP relationship. And the policy is this. From A to X, 60% of bandwidth should be consumed. The traffic goes from A to X, can consume up to 60% of the bandwidth on the link. Whereas X to A is only 10%. So totally 70%. The rest 30% is kind of buffer. Likewise, below also you see like between Y and B, it's 75%. Between B and Y, it is 20%. So this is one example for policy-based routing. BGP is designed to manipulate routing paths. See, you need to understand one thing. BGP is only a routing protocol. BGP is not a protocol that will give you a statistics of how much bandwidth, who is consuming. No. The 60, 10, 75, 20, these percentages, we need to discover through some tools. Now, if you have identified some traffic consuming 60% of bandwidth, then you can match it and use it along with the route map. So don't have too much expectation from BGP. BGP is not a tool which is going to provide you the statistics of how much traffic, who consumes. This is not a QoS topic. To get more clarity on this, let's see an example. Question is, from C, router C to Z, from router C to Z, which will be the best path? Will it be X or Y? Please answer.
Y.
Why? Why? Why?
So X, it will pass through the two autonomous system, you know.
Okay.
The Y is only single hop.
Yeah, there's only one hop. Actually, two hops in total. Whereas going via X is three hops. So going via Y is the best. Fine. So to reach this network, instead of Z, I want to mention 172.30.00. To reach this network 172.30.00, which is an autonomous system 65004, you said we have to go via Y. Fine. To reach 172.16.00, what is the recommended path? What happened? To reach 172.16.00, what is the recommended path? Which path should router take? Seed should take. Please answer, no? To reach this destination, should I go through X or Y?
The both.
If I go via X, it is 1, 2 hops. If I go via
Yes.
Y, it is 1, 2, 3 hops. So what is the recommended path?
It's 2.
Means should I go via X or Y?
X.
Okay. We should go via X. So to reach 172.16, I should go via X. To reach 172.30, it is via Y. Now tell me, to reach 172.24 network, which path is recommended? Straight to X, straight to Y, or I have to go via X? Of course, straight to Y. Yeah? Fine. See, I'm asking this question. The reason is there is something coming based on this understanding. So don't hesitate. Even though it is easy, just say it's okay. Even if it is LKG question, kindergarten question, try answering it. There is a reason why I asked this question. So we can see here traffic to 172.24.0.0/16 and 172.30.0.0/16 going via Y. And only the traffic that is going to 16.0.0 is going via X. Now, with this understanding, let's jump into this page. Listen here. 30, 24. 30 is 20% of traffic. This is 20% of traffic. 16 is 10% of traffic. 10% of traffic. 24 is 30% of traffic. Okay, now someone tell me via Y, how many percentage, how many percentage or how much traffic goes via Y and how much traffic goes via X? In percentage, how much percentage goes via Y and how much goes via X?
30. So 60% Y, 60% traffic, sir.
60% of traffic goes via Y.
Yes.
And only 10% goes via
X. Yes.
Only 10%
Yes.
goes via this way. 60% goes via Y. If I need to load share, what I have to do?
Metric. Sir, wait. Increase the weight.
See, I did not ask you about attributes. If I want to equally share the load between X and Y, what I have to do? Right now, via X 10% only. Via Y 60%. If I need to load balance, What I have to do?
Put more traffic on X.
I'm sorry?
You have to put more traffic through X, basically.
Okay, which one I should put to X?
So 30. So both. Oh, sorry. Okay, go ahead. So for the prefix 172.24 and for prefix 172.30, put parts of that traffic to via X.
Sir, C and A, a local preference I set to the X.
Sheikh G,
Yes.
you need to understand the scenario first. What are we talking about? I'm not asking you anything related to attributes. In one path, 60% of traffic is going. In the other path, only 10% goes. If I want to load share, if I want to have equal load on both, we have to take, as our Gaurav said, we have to take some of the traffic that is going to Y, we have to take the traffic and put it into X. So my question next I've asked him is, which traffic I should put into X, which traffic I have to take from Y, which traffic I have to take from Y and give it to X. That was my next question. What do you want to answer? One to 30 is 20.
Yeah, so it's 50 total. So 50 and 10.
It's 20. So this is 50 and 10. If I need to load share, what I have to do?
So basically make like 30% traffic go through X and 30% go through Y.
Wonderful. This is what I'm expecting. 30% of traffic should go via X and 30 should go via Y, which means currently the traffic going to Y is 50. I need to find 30% or 20% of traffic which goes to Y and give it to X. 20% of traffic, if I take from Y, then traffic going via Y will become 30. And the 20% when I give it to X, the traffic going via X will become 10 plus 20, 30. So now, how are we going to do this? Which traffic should I take and put it to X? Should I take this traffic, which is 30%? No. I just want to take 20%. So two reasons why I take this traffic and put it into X. Two reasons. One, if I put this one via this way, then it will be too long distance to come back, to reach. That is one reason why I do not want to put 172.24. I want to put 172.30 because it is only 20%. It's only 20%. Instead of sending the 20% this way, if I send via this way, that becomes 20 plus 10, 30%. 30% via the upper path, 30% via the below path. So this is an example case study for policy-based routing. From where you got that 30, 20, 10%, that is because of someone auditing monitoring the traffic. They have given me a report saying 30% of traffic goes to Y172.24 network, 20% of traffic goes to 172.30 network, and 10% goes to 172.16 network. So for us, it's like an assumption here. They have given us, assuming these numbers, currently the traffic that goes to 16 is going via 28.1, which is the upper path. This is the address of X. You see, 28.1. Y is 50.1. So if you see Y 50.1, greater than symbol, 50.1. What we want is, we want the traffic going going to 30, 130, which is this one. We want this one to have greater than symbol here, not here. So that this will be the elected path, X. So this is what we need to achieve. We need to have greater than symbol here. That's the elected path. The path with the greater than symbol is the elected path. This is, you see, greater than symbol, elected path X. These two are Y. How do we achieve this? Let's see. To achieve this, I need to match with this prefix. You see, I match with that prefix. I write an access list and I match with the prefix. 172.30. That is a 20% traffic destination. And then I write a route map, give any name. You don't need to say even permit. The default is permit only. And there's a sequence number. You see here 10, here it is 20. Same name. It is same route map with different levels. Sequence number 10 will be processed first. And then only sequence number 20, if 10 is not matched. So here what I do is I call the access list. And I set local preference 400. Where I do it on router 4. Router A. I go to router A and I set 400 as a local preference if the prefix is 172.30. So that will make all the routers in this autonomous system, as our Sheikh was trying to say, local preference. Even B will start sending the traffic via X if it wants to go to 172.30. Sorry. You see? Now, why do we need this one? For those prefixes that did not match this access list, I do not want to take any action, so I need to simply create this. If you don't create this, the other prefixes will not be allowed. The update about other prefixes won't come. Listen, we are going to bind this with X. We are saying when I am receiving the update in from X, check the route map. If the update contains 172.30, then put 400 for that network as a local preference. And this one, for the rest of the prefixes coming from X, you don't need to do anything. That's what this means. You have not mentioned anything here. We have to write this sequence number 20 route map. If not, there is going to be implicit deny at the bottom. Same like what you have learned in access list. Ask me a question. After you do this, the output will become like this. 170 to 30, earlier it was going via 50.1 because of the shortest AS path. But now, before AS path comes the local preference. Is that right? Before AS path. First is wait. Second is local preference. And then only comes the AS path. So because you set local preference 400, you see the greater than symbol now. Yeah. So 30% of traffic's next stop is Y. 30% of traffic next stop is X. Load balancing is achieved. We used access list, use route map. Inside route map, you call the access list, and then we can set the local preference value under the route map itself. You no need to do that local preference configuration under BGP, because in the route map, BGP related attribute commands, OSPF related commands, RIP, EIGRP, all are available. That's why I said it's a very, very advanced route access list.
So the main thing here is the route map, which helps to apply the manipulation that we want to do.
Correct.
And so in this example, if we lose the peering with router X,
automatically the traffic will switch to, because the peering is gone, this will be vanishing,
right,
and it will go here automatically, right, because you got alternate path.
Okay, so it doesn't affect the other part.
Yeah, it don't affect. So this is for one particular prefix. If you want to set local preference, we use this policy. But if you don't have this type of scenario, you want all traffic to go via X, then you don't need route map. You just set by saying BGP default local preference a value. BGP default local preference, and you give 400. So it is not only for this destination, for all destinations, it is going to be via X. If I go here and give this command under BGP 400, anything this router advertises will have 400. All those things B advertises will have only 100. So this network B advertises Also, A advertises like this network, this network. So for any network, A will start going this this way, this way. See, if you want to impact the path selection for all prefixes, you need to simply use this command. There is no need for outmat access list. But when you are trying to match one particular access list and one particular destination, and only for that destination, if you want to set local preference, like we saw in the case study, you want to do load sharing. So you want to only match with those destinations, that is 172.30 updates coming for the network 170.30. Then you need to write access list. I need to call it under route map. And call the route map with the neighbor statement as the update comes from X, the neighbor. This 200 tagging, 400, the local preference is tagged, attached.
So just one question. So going back to the diagram, so whenever we apply the policy or whatever we want to change the routing, it is applied on A. Like, I mean, in this example, we have applied it on A, and we are applying it on all the routes received from X down to A. And then selectively we are telling A, choose this route. If this is the route being received, set local preference for that to be higher value, so that you use me to route the traffic through to that prefix. So if there is a case wherein X is not advertising that prefix to A, and is only advertising, let's say, a default route, then the application of route map will
not be active.
So then what would happen? Will not be active, right? So it would just be, okay. It is just based on the prefix.
Yeah,
then.
match is not found.
Okay. So then default behavior will happen in the AS 65001.
Right.
I see. Okay. All right.
So the reason why we wrote this second line is there are other networks X is advertising. X is not only advertising 176.30, it is also advertising 16. For the 16, we do not want 400 to be added. It is already going via this way. So that will be allowed because of this configuration. If you fail to configure this, 172.16 will not be learned on A from X. Do you have a question? All right. Changing BGP MED for all routes. This is a simple command. For all routes, if you want to change MED, default MED. Again, you know MED. MED is only between the dual homing scenario. So here they have an example. It's a dual homing. To reach this network, and this network, this is customer. Customer can come via A, can come via C, can come via, you can come via A, can come via B. But we want to have a load sharing like this. Based on the output that you see here, tell me if Z wants to go to 172.16.25, what will be the preferred path? Will it be via X or via Y? To reach 25.0, which is in here.
Why?
To reach here, it will go via X or Y. Check G. Will Z take this path to reach here, or will it take this path to reach here? Which path?
X, sir. X.
Why, sir? Why via X? Why X should take A as the path? Why not B? I ask you why because you said correctly. Your answer is right. So you need to tell me now why.
The MED is
MED?
the value to
MED?
MED value is high.
Where?
162.
So give a clear
No, sir.
answer, no? You said it will go via X. And now you are talking
No,
about MED high for 20.
No, sir. Why, sir? If you choose, why, sir? Why the MED? I think 200. 190 to 160, 24.0. The MED value is 200.
Sorry,
I think it. Sir.
I asked for 25.0. For this destination, which path will be taken by this autonomous system? Which path will be taken? Will it go to A or will it go via B? Will it go out via X or will it go via Y?
Why, sir?
Why, sir?
Why?
You told me correctly before. X is the right answer. Why Y?
I check the.
Is lower med preferred or
Correct.
higher med?
MED lower is preferred.
Okay.
Here it is 100. Whereas here, this is advertising 200. MED lower is preferred. See, MED is actually stands for multi-exit discriminator, but it is also called as metric. You know why? Metric only smaller is preferred.
Okay.
All right. So
I understand opposite. That's it.
you understood opposite, huh?
Yes, higher only.
Now to reach 26, which router will be exit, X or Y? To reach 26.0.
X.
X is the option. To reach 24.0, which way is the exit? X or Y?
Y.
Y. So this is what we are trying to achieve. For this, I need to write access list, you see. On router A, here MED we configure here, the impact will be here. MED you configure here, the impact will be here, don't forget. So we configure on A for this two network 100. You see, for these two network 100. For those that did not match access list, which one is not matching access list? 25, 26 is matching. What is not matching? 24 is not matching. For that, we give here 200. We don't need to write an access list, you know. If these two matches 100, MED, metric, If this 2 doesn't match, it will get matched here in the next biggest sequence number. You don't need to say 100, you can say even 20 or 11. The smaller sequence number will be processed. If no match, then it will process the next one. So 200 will be given for the network 24.0 on router A. For the rest, MED is going to be 100. That is how we achieve this. Likewise, you go to B, you match only 24 and give 100 for the rest 200. You see, match only 24 and give 100. For the rest, 25, 26, you don't need to write access list. It gets matched here. So that is all route map policy-based routing. All right. So whatever we have learned is what shown in the output here. All right. So the other things are like lab. We are going to see BGP Enterprise. We'll have a demo. So today what we have seen is an example case study, means a case study to understand how to use attribute. We saw an example policy-based path selection. We use local preference, we use MED in our example. In our next class, I'm going to demonstrate with different case study. Much better than what we have seen today. A different case study. All right, so go through this video once it is ready and upload it. Go through this video, come back. The next class, I'm going to do a demo with different case studies. Okay. Any question?
So just one thing. So MED also gets distributed within IBGP,
No,
just like local
it will
preference.
go like this. You see, MED will go from here up to X. It will go.
Okay.
Up to Y it will go, and it will also reflect here. Even though the action is taken here, it will reflect here.
Okay.
See, for your question, the answer is yes. It will get distributed to IBGP. I would have said that directly, but why I'm saying this,
Right.
we should not think that if I configure on X, it will impact on Z. No. If you configure on X, it won't impact Z. So if I would have said yes for your question, that means this also. If I configure on X, it will go to Y. No. That is not. You configure on eBGP, that will be carried into IBGP. So,
I see. Okay.
So you configure on A, X will carry it to A, Z also. But configure on A, other autonomous system. Within the same autonomous system, if you configure, it won't go. It won't go to the next router. So whatever you configured here, it won't go to C.
Right.
It won't go to C.
Okay. So basically, for MED, the configuration is applied on A and B.
Correct.
Like the border, and then what you're saying is on the prefixes. For those prefixes, change the MED value. That's it. And then, so let's say the traffic comes to A, and it is, and if it has a higher MED value, or actually a lower MED value, then it has to go to B then for exit.
Yeah.
Like say for example 25.0.
For A 24.0, for A 24.0,
right.
So not for A. For Z 24.0, for X 24.0 will be via Y.
Right.
Via Y. It won't go straight like this. Why? Because it is 200 here. So it has to go via Z, Y. That's what you are trying to ask.
Okay.
Correct?
Yeah. So like the thing that we discussed here is we apply the policy on A and B only, and it gets propagated through eBGP to X and Y.
And X and Y will also give it to Z.
Z. Okay. Yeah. Okay. Got it.
So similar lab we will be doing in coming days. It will be much more than this. Any other question?